Now we're here on the interface node. We're looking at the configuration of this OPC interface using interface configuration utility. And one of the things you'll see here among all the different parameters, you'll see something called a point source. The point source is what we use to identify which set of tags out on the out on the Pi server this particular interface is going to start gathering data for. So you'll see that there's a congruence, a mapping one for one to the point source defined here and to the tags that are being scanned by this interface. Let me demonstrate. If I go back to my home node, my Pi server, and I look at that tag that I created earlier, that OPC tag, take a look at the point source field. Yeah, no big coincidence here. That's not a coincidence, I should say. That OPC is specified in this point source. We specify OPC because we want this OPC interface on the interface node to start gathering information for that and start scanning data for it. So you define the point source here, and then you exploit that definition over here when you build the tag. Now, there are many different point sources. Let's take a look at this point source table. Here's a list of them. They're currently used against this particular Pi server. As you can see, there's the OPC point source. We just looked at that. I've only got one tag that's using that right now. There's R. R stands for random. I've got 122 tags on this system that is using the random interface. Two that are using L. L stands for lab. It's basically getting data from no source. And that's all that's really defined at this point. Now, some of these point sources, I should point out, are things that you can configure. I should say most of them are things that you can configure right here on the interface node, in interface configuration utility. However, some of them are not. You will notice that some of these interfaces simply cannot be modified. And if you take a look at our documentation on this, the class documentation, we have a list there, the totalizer and L for lab tag. Those are two point sources that simply can't be changed. So T for totalizer, L for lab. And some of these point sources can be changed, but they can't be changed from here. They're changed instead by making a registry edit. So for example, the @ symbol for the Pi alarm, that's something you have to change through a registry setting on the Pi server. Anyway, all of these things that we're talking about, and we're going to talk about in this video, these are startup parameters. I define the startup parameters in the interface configuration utility. Okay? And then those are the parameters that are being used by the interface when it starts up. So when this interface starts up, it's got a very, very basic question. Which tags do I need to scan? And so it's using that point source to map to this list of Pi tags over here. It's going to find every Pi tag that has that same point source, and it's going to start gathering its information so it can do scanning. Remember, with the blue background, we're on the home node here. This is on the Pi server. We're looking at the point database. This point database may have tens of thousands, hundreds of thousands of tags. We need some mechanism to keep the interfaces apprised as to which tags are of interest to that interface, and we do it through point source. Now, a second startup parameter that you'll find back here on the interface node, a second startup parameter is called the scan class, or scan frequency as it is identified here. And what this simply means is the frequency with which we will, or by which I guess, we should scan the data source. And in this case, we simply count down from the top. This is scan class 1, 2, 3, and 4. And in this case, it's 1 second, 1 second, 1 second, and 2 second scanning for these 4 different scan classes. Now, how does this map over to your point definition? Let's go back to the home node, to the Pi server, and let's look in the Classic tab. In the Classic tab, there's a set of obscure fields, and one of the obscure fields is called location code 4. Location code 4 in this case is 2. Well, it's location code 4 for all of our interfaces that indicate what scan class it should be. So in this case, we're saying location 4 equal to 2. That means that we're going to use scan class 2. Let me go back to my interface node. Scan class 2 for this interface means 1 second scanning. Now, I'll confess, I haven't really been telling you the whole truth about this field here. As you can see, this scan frequency of 1 second, that's a valid scan class. Let me show you another valid scan class. I'll go ahead and create a new one here. I'll choose add. I can choose, let's go with 0 hours, 0 minutes, and 10 seconds. I can create a scan class like that. That indicates it's going to be scanned once every 10 seconds. But I can also create a scan class like this. 10 seconds, comma, there's no space there. Let's go with 5 seconds. What this is this is a combination. It's both a scan class and an offset. So if I can highlight this here, that offset right there in red, that indicates the offset from the 0 mark on the clock. So if I'm scanning once every 10 seconds, but I'm offset at 5 seconds after, it essentially does a scan at 5 seconds, 15, 25, 35, etc. Let me show you. There's a nice illustration in the book you'll find. This is in our class material. If you were to simply set up a scan class of 10 seconds, and then you were to start your interface at 2 seconds after the 0 mark there. If you were to start your interface at 2 seconds or any 10-second multiple of 2 seconds, then exactly every 10 seconds, offset from that time when you started it, that's when you're going to get a scan. Now compare that to this. In this case, we're using this, it's a scan class of 10 seconds, but an offset of 5 seconds. What we're going to do is we will specifically do a scan at the 5-second mark, the 15-second, the 25-second, etc. Now, why is this important? Well, sometimes for purposes of staggering the load, you may actually have 2 different scan classes, both at 10 seconds, but one scans at the 0 mark and the other scans at the 5-second mark, so that you're not scanning all thousands and thousands of tags at the exact same time. So that can be a useful feature. Now, one more thing about these scan classes, in addition to using this hour, minute, second for both the frequency and the offset, you can also just specify this scan class and offset in seconds. Let me demonstrate. If I go back to my interface node, I'll add another scan class. This is a scan class. Let's go with 30 seconds here. If I just type in a scan class that simply omits the hours and the minutes and just specify seconds, then that will give me a 30-second scan class. And if I were to, let's go ahead and modify this and do a 30-second offset at, let's go with 0 seconds. Yeah, it's 30-second frequency, 0-second offset. This is going to scan at 0, 30, 0, 30, etc. every 30 seconds starting at the 0-minute mark. So there's 2 different formats you can use for this. Now we've tried to document this for you. You'll find this in the class documentation, and you'll also find it in the Unient user's guide we're going to look at in just a second. Except you'll notice that in these guides and in a lot of the materials that we've printed for the interfaces, for example, the interface documentation, a lot of those use a rather old-fashioned way of expressing this. And the old-fashioned way of expressing it is using these parameter switches that are used even to this day in the batch files that can be used to start up the interface interactively. So let me back up to my interface node here. This takes some explanation here. Let me go ahead and save this. I'll show you exactly what's going on here. See, I've just made a change to this. It's warning me, by the way, that this is not going to take effect until the next time I stop and restart the interface. Fair enough. But the changes that I've made right here, we've stored them in a couple different places, but one of the places we've stored them is we've actually stored them in a batch file that is associated with that interface. This was the same batch file that I loaded initially when I brought in my default values. And if we take a look at this batch file, the first thing you'll notice about it is there's all kinds of warnings. Do not edit this manually. That's because we're currently allowing ICU only to edit this. We're asking ICU to be the manager for this. Now, if you're using ICU, which we strongly recommend you do, we don't recommend you ever edit these files by hand anymore. In most cases, unless you're on the phone with support, they may tell you different sometime, but rarely. Anyway, to make a long story short, our old friend, the /f parameter, the one you saw from our documentation, our class documents, you also find it in our Unient documents and some of our interface manuals. /f stands for frequency. And before we had this wonderful interface configuration utility to make it all nice and user-friendly like this, before we had any of that, we simply edited a batch file. So those changes that you just saw me make, I added there we go, here it is right here, the 10-second scan class, and then here's the 10-second scan class with the 5-second offset. Here's that third one, the 30-second scan class with the 0-second offset. All of those are going to be stored in this batch file using these switches, these parameters. And that brings me to the grand finale of this video, which is, at some point as you're working with this, you're going to say, what in the world do all these switches mean? Where do I go to find out more about, /PS? That's point source, by the way, in case you're curious, because that's the one we were looking at earlier, remember? OPC. Anyway, yeah, so where do we find the definitive word on /TS and /max stop time, etc.? How do we learn all that? Well, the official, or I guess I should say the authoritative guide to all of this is this Unient Interface User Manual. You'll find a little bit of information about scan class in the actual documentation for your interface, but I tell you what, you'll find an awful lot more if you go down to the standard parameters section of this Unient guide. This is where you're going to find in nauseating detail everything we've ever wanted to document about these switches. And as you can see, they are shown using that old syntax. I don't even know if the word interface configuration utility is even in this document, because we're simply documenting this using that nomenclature that we originally designed all this with, these interfaces with. So these switches, what does the /host parameter mean? What is the what are some of the other ones? The max stop time parameter. What do these all mean? You'll find the official documentation for this in this Unient guide. And by the way, and hopefully this is not going to catch anybody by surprise, because it would be kind of much you might guess at some point, is the things that you're seeing here as individual little fields within this Unient section here for PySDK, disconnected startup, debug, etc. All of these are things that you will find documented in this Unient guide, because as I said, they're simply startup parameters. Now we've gotten to the point where we're not asking you to edit those batch files anymore. We've got a nice graphical user interface. But of course, at some point in troubleshooting or in working with this interface, you may want to know, well, where do I find the absolute last word about these switches, especially these Unient switches? How do these health points work? How does these debug flags work, etc.? When you need to learn that, again, go back to this Unient interface guide. You'll find one of those in the documentation that came with the computer-based training. You'll also find this available for download off of our tech support site.